So the two cool things this allows you to do is, the biggest one is it allows you to stick to things that God and man never intended to be docked to, you know? I mean, for instance, you know, near-Earth asteroids. You know, you have no idea what the surface of a near-Earth asteroid is like until you get there. One of the big NASA science objectives is to do a sample return from a near-Earth asteroid. The problem is, because you don't know what its surface makeup is until you get there, and this could be a $300 million mission, you want to have a way of grabbing samples off of it, anchoring to it, what have you, even though you don't have a priori knowledge of, is this thing a rubble pile, is this solid rock, is this, you know, there's even some studies that suggest that some of these may be dust balls. You know, not even a rubble pile, but like actual like regolith pile. And electrostatic adhesion, electrostatic sticky booms enable you to do that. Yeah, not only can you grip the surface and grab stuff off of it, but you can do it with your spacecraft at a safe standoff distance, so you're not getting, you know, crap killing the, you know, stuff on your solar panels and radiators and messing up your spacecraft. Other examples: orbital debris. You know, in many cases it's stuff that we know. It's like a spent upper stage or a satellite. But instead of having to design a non-cooperative capture technology for a specific spacecraft and then another one for another one, you have a general purpose system that can just stick to anywhere on the spacecraft. This does all sorts of things for you, like enabling you to de-spin massive tumbling objects, you know, without having to know in advance what the material makeup of it is, what the mass properties are. Like, there are ways to actually do these missions without having to have detailed knowledge in advance of what it's attacking. Or what it's latching onto. So, I mean, for us, like, that's where we're initially focusing, because there aren't very many good solutions in this space, and we happen to have stumbled on a great one. The other area we want to move into once we've demonstrated our capabilities on objects like that is, you know, more like space station and depot kind of operations, where now you're trying to take something where they've already got existing solutions, you're trying to improve on it. You're trying to provide a solution that, you know, because you have this low inertia boom where you can move the tip around fairly fast, you can tolerate much bigger mismatches in velocities and roll rates and things like that, that mean that you don't have to have as much precision on your visiting vehicle. We're still investigating the problem. I don't know how far we can push this, but what I'd like to see, if it's possible, is for a visiting vehicle, like, well, an existing upper stage, like say a Centaur upper stage, to take a payload into the vicinity of this station, and it's a dumb payload. Maybe it's a tank of propellant with some valves on it, and a passive coupling device, and the station takes over from the upper stage. You know, like right now when you look at deliveries to space station, it's like Soyuz, Progress, Dragon, ATV, HTV. In most of these cases, you know, you've got like a 15, 20,000 pound vehicle that's delivering a couple thousand pounds of cargo. It's mostly wrapper with only a little bit on the inside. And what I'm hoping to do, and that's a very expensive wrapper that you're usually using once and throwing away. And what I'm trying to see is it possible to get rid of most of that wrapper? You know, make it so that most of the payload you deliver to LEO makes it to your station. Because I mean, this is critical, especially for reusable launch vehicles that, you know, are carrying recovery systems. Are probably going to be small vehicles at the start. They don't have a lot of mass to duplicate the full rendezvous and docking suite that goes on a, you know, on a Soyuz capsule or something. The more that you can offload onto, say, something that's just on the station side, or, you know, maybe if that doesn't quite work, you could use a tug as an intermediary. But offload as much of the smarts and as much of the weight and complexity from these delivery vehicles to stuff that stays on orbit, you know, that isn't coming back every single time, isn't being disposed every time. So that's kind of what we're trying to do with this. We won a NASA SBIR award this last December. Got started on it in February. This Phase 1 SBIR award is for the Mars Sample Return Mission.
Now, SBIR stands for?
Sorry, SBIR, Small Business Innovative Research Grant, yeah. So basically, NASA JPL has this mission they want to do in the next decade and a half, the Mars Sample Return mission. I guess it's sometime in the next decade, where they want to grab some Mars rocks to bring back to Earth to study on Earth. And part of that mission is, you have a Mars orbit rendezvous, much like on the Apollo program, but this has to be totally autonomous. It's unmanned. You've got a 30-minute light delay, speed of light delay back and forth, and
so you can't remote control.
Yeah, you can't remote control it. You send the go command, and then about an hour later, you find out if it worked or if something bad happened. So anyway, so they need some way of, you've got an ascent vehicle that blasts this basketball-sized container with Mars rocks on the inside, blasts it into Mars orbit. You have to have some way of having your orbiter spacecraft grab that, stuff it in an Earth return vehicle, and send it home for study. And anyway, so they gave us this Small Business Innovative Research Grant to study using our sticky boom idea for grabbing that sample ball, and so we're doing some things like studying space environment impacts on this. Will this work in vacuum at the extremes of temperature you see in space and other space environmental issues, and to start maturing the technology further. We're also putting a decent chunk of our own money and time into this. This is something we really believe in that we think could make a huge difference for the industry. So, we're a small company. We've been in operations for barely 6 months. We've already rolled probably about 10% of our revenue into like prototypes and things like that to keep pushing this forward. It's kind of crazy. We're really trying to drive this as aggressively as we can. I'd like to see this, demonstrated in space in the next 3 to 4 years. And I'd like to be selling integrated sticky boom solutions, complete with all the mechanisms, all the controls, the control algorithms, the relative navigation systems, or maybe just packaged with us. But the whole system, I want to be selling that to third parties that want to use it for space science missions, space servicing missions, things like that, where maybe one of the big primes, Lockheed or Boeing or Northrop Grumman, has a satellite that they're trying to do a specific mission for, and we'd be building one of the key subsystems for that. And so that's kind of the goal that we have. It's my background in mass and space systems with suborbital vehicles is a totally different world. Selling flights on a launch vehicle by the slice versus selling a single mechanism that might be worth something on the order of $10 to $20 million, depending on how complex and how many bells and whistles they need. It's a totally different ball game, but it's also kind of exciting. I mean, this is one of the few space business plans I've had a chance to be involved with, where I could really see the potential to make, not just make a profit, but make a difference at the same time.